Welcome back to this session of the Big Data and AI Conference. My name is Bill Wong. I'm with DELL Canada, and I lead DELL's AI and data analytics practice in Canada. In this session, we'll talk about AI-powered digital transformation, spend a little time on some of the current challenges customers are seeing today, spend the bulk of the time talking about building the AI ecosystem, and also the multi-cloud deployments. Now, data readiness. This is a study that we commissioned Forrester Consulting to do on our behalf earlier this year. And as you can see, if you take the two axes here on the left-hand side, data culture, advanced data skills versus having the technology and data processes in place, the study shows that 88% of our customers out there are facing challenges. Only 12% are deemed as data champions. And I guess I would have to agree. See a lot of data novices out there, and it ranges from small, medium to very large organizations. I was at a place virtually recently. They're a $10 billion plus firm in Canada, and how they make decisions still is more, I would say, more gut feel than anything else. They do use analytics for reports, but that's about it. Nothing to help them try to predict what's coming down the pipe outside of their experience. I do meet a lot of organizations with a lot of skilled data folks, but they do get into arguments about what the platform should be, which kind of prevents them from going forward. And then there's a lot of technical people skilled in data, but the culture is not really there to use data as an asset going forward. So lots of challenges out there, but the payoff's worth it for those data champions who are kind of showing us how to get there. This survey was provided to me by my colleagues at NVIDIA, and this was done with 200 subject matter experts in the financial service industry, and that was earlier this year. And the challenges that they saw were still subject matter experts. There's still not a lot of data scientists out there. It's better, but that still is a bit of a challenge. On the bottom part of the screen, it's interesting. You find the fintechs, the investment firms. The big benefit and payoff of pursuing AI is really to get a more accurate model to predict better. While if you're in retail banking on the far right, the big, I guess, value proposition or benefit they're trying to pursue is operational efficiency. So what do these companies have in common? I believe most everybody here will recognize these icons, except perhaps this one down here. This one might not be as well known as the other company logos. And that belongs to a company called Graphcore. It's a unicorn, a billion plus company that manufactures chips. Talk about them in a moment. But in building your AI ecosystem, one of the first things people will look at is what AI accelerator or chip technology you should use. And if we take a look at the spectrum of offerings here, on the far left, we have CPU, which is the most flexible, and Intel, AMD, well-known providers of CPU-based technology. And then GPUs, where NVIDIA today is kind of the dominant player there and differentiates itself to do vector processing in parallel. So it's very good for deep learning algorithms. Field programmable gate arrays, firmware that you can code, so a little more flexible. But I only see these typically in kind of niche vertical applications, manufacturing, some in retail. And then on the far right here, your application-specific integrated circuits. So these are highly optimized chips, and so you can get things to do like driverless cars. They're very specialized. They do it a lot faster, a lot cheaper, but that's all they can do. They're not as flexible. But that's where all the startup capital is going. So a lot of these will be deployed in IoT type devices, but there will also be in servers, and that's where GraphCore put in a plug for DELL. DELL servers, first one to offer a GraphCore based AI server. And if you take a look at the table here, we do see a demand, shouldn't be a big surprise, of GPUs going forward. Now, GPU workloads outside of AI, the pillar you see here toward your right, there are other workloads that you optimize their chips for. To the far left, your edge, but we do see a lot of demand for virtualization support, virtual desktops, GPU virtualization, which is kind of new in this area. We'll talk about that in a bit. Data analytics. So if you're a user of Spark or Cloudera, there's optimized versions of those packages to run on a GPU platform. AI, well known for that, but also at the very high end, used for your classic HPC simulation type workloads. So with that in mind, we'll just talk a little bit about each of those workloads. So on the edge, what we're seeing is more interest in real-time analytics. People aren't satisfied or can't really compete if you do analytics the regular fashion where you might get an answer back in 2 weeks. So as we push toward more real-time analytics, we're seeing more solutions here, more of a focus on streaming engines here. So Kafka, open source, very popular, and Spark put in a small plug for the DELL EMC streaming data platform. So folks may not have heard that, but that's recently entered the market. Splunk, well known as well. Common use case there is typically for security and Elasticsearch. So best practice as you engage for these edge type of analytics is to build a repository, a data platform to ingest, to build a centralized platform, to discovery zone, to transform that data, put then on an optimized platform for performance. And again, as I said earlier, big push toward more and more real-time based analytics. So talk a little bit more about the edge, computer vision, but a branch of that is thermal vision, and we're starting to see a lot more than that. These are specialized cameras that you can't use existing cameras, so these things see things like underneath that normal cameras can't. So a lot of interesting applications out there. The DELL strategy is to work with the partners here, but we do see quite a marketplace for these kind of IoT devices. And then regular computer vision type of applications. I mentioned thermal vision, but in healthcare, a large part of the AI is being used there to do image diagnosis, agent video intelligence or surveillance, safety and security, other very popular applications in using and leveraging computer vision. Now, I mentioned before that the virtualization is kind of new here. So when GPUs first came out, there really wasn't too much spent in virtualization, partly because everybody wanted to use every compute component of the GPU. But as more and more users came on board, what I've heard from a number of customers is that they want to increase utilization. So hence the demand for virtualization. So these are recommendations by NVIDIA, the A100 and A30 of the compute workloads. As you'd imagine, the higher type workloads, the training, the better suited for the A100, their top of the line chip. A30 can do the lesser strenuous workloads such as inference. And now what NVIDIA did was tap the shoulder of the VMware folks, and they've come together with software here to provide virtualization for GPUs. So NVIDIA AI Enterprise is a software stack that provides this, plus a software stack on to accelerate AI development. And here's that stack. We'll call out the particular NVIDIA, but the normal CUDA libraries would run here. The thing to call out here is on the left-hand side, today, the hardware infrastructure that's been certified to run is the DELL servers, DELL storage, etc. But where this is going, and as if you've heard, VMware is branching off into its own entity. There'll be NVIDIA certified servers there, so any hardware server that's certified would be able to run the NVIDIA AI Enterprise stack and provide virtualization through VMware vSphere. And just around the corner too, for Canada, you'll hear lots from DELL about Apex. This is their multi-cloud solution to provide compute and storage as a solution. So earlier this year, Gartner released their Magic Quadrants on data science and AI developer services. Not sure why they felt the need to separate the two into two different quadrants, because if you take a look on the right, which is just really the cloud vendors, and you'll see the regular suspects here, Microsoft, Google, IBM, Amazon. When you map them over here, generally what you'll find is the on-prem tools are better than the cloud vendor tools. But this way, I guess if you have another Magic Quadrant, they look like they're in the leadership quadrant there. Data platforms, I always find it interesting to understand what our customers are using. And on the right is a survey that's taken. Now, this is from a developer perspective, and companies that I've worked for before, Oracle, DB2, not generally that popular from a developer's perspective. From a data perspective, generally they are, because there's a lot of critical data there. But generally the theme is that the open source, the non-SQL databases are the more popular and growing databases of use. Now, what this slide is attempting to show, and we're picking financial services as a use case here, is the pipeline for analytics are getting more complex, so that just running simulations for Monte Carlo risk analysis is not enough. You want to take those results and feed it into an AI algorithm, or sometimes just AI is not enough. You want to combine it with simulation. So we're seeing more complex analytics pipelines. And because of that, what we've done is create a solution that allows you to use a single infrastructure to handle both HPC type of simulation workloads and AI type of workloads. And if you go to GitHub, there's an open source project called Omnia, and it's our set of libraries there that you can install so that you can deploy AI type environments given an HPC platform on demand. Now, as we move toward cloud, we've seen a lot of firms right now with directives to put everything on the cloud. But I think most of those directives have slowed down a bit, and they said, hey, does it really make sense to put everything on the cloud? And people are taking a perspective saying, and asking themselves, okay, what makes sense for the business? Should petabytes of data go up there? And are we feeling that this is the best place for performance, for security, governance? And so many people are really assessing what are the data needs and qualities first before going to the cloud. And we take a look at public cloud adoption. And this is an annual report that comes out. And I guess the big news here, the big three, there's no big surprise there that AWS, Azure, and Google are the top three in consideration for public clouds. But what may be a surprise to many is that the fourth cloud is actually VMware, and its cloud imitation, this is only based on AWS. So if you include the hybrid type solutions that are coming out there on with every public cloud vendor, those numbers will be bigger. Now, why multi-cloud and AI? So if you've developed AI applications, you know that training is very compute intensive. And for a lot of folks, it's much cheaper, less expensive to put training on the on-prem platform. And you may deploy on the public cloud platform to get better reach, but many people, for cost effectiveness, are putting training on the on-prem platforms. When we get asked to develop an AI strategy, we go from first principles that we learn as enterprise architects, is that you should really have a big picture view of where you want to go with this technology. And in defining a roadmap, it should also include kind of a cost-benefit analysis and interim steps, so interim deliverables, not this big bang approach. So if you are an enterprise architect, you'll recognize these kind of steps from your TOGAF type of architecture plays and a best practice going forward for building AI applications. Now, what we're seeing with a number of firms here is the move toward a model-driven environment. So not having to actually need like low-level Python programmers in the future, but today there's still probably a healthy demand for that. But on the left-hand side, we see organizations with multiple AI efforts going on right now. And each AI initiative is driving a separate infrastructure, separate set of tools. So, and then the timeframes here too. So building a model can take months. This data discovery, really understanding the environment of the data, and if it's been cleansed and it's sourced, that can take weeks. And then installing the platform, the infrastructure can also be very time consuming. So as we move to the right toward a model-driven environment, we'll start with the platform as service. So there are tools out there today that can deploy the storage, the software with a touch of a button. That might take 20 minutes, half an hour to deploy, but much better than the weeks or months. The data service, so data catalog, a very popular tool that you're starting to see out there, and a great tool to provide self-service type capabilities so that you can see the landscape of what's available for your application. And finally, machine learning as a service, getting toward, if you use tools like DataRobot, you don't really need to know how to code in low-level languages anymore. It'll come up with the algorithms that will show you, what can be done with these algorithms. So that's the environment that we're going toward. And some your data champions are doing that today, but most are trying to work toward this vision. So this is another look at the available tools out here, this time more from a use case perspective, and we've mapped out some of the more popular solutions that we see out there. So on the far left here, starting with streaming applications, I've already called out Kafka and Splunk, Elasticsearch before as some of the popular tools out there. The augmented analytics, your classic data warehouses. Kinetica is an example of a GPU database that, not like the Oracles and Microsofts, but one that's optimized to run on GPUs. ThoughtSpot's an interesting BI tool, and it's in a way, transforming how queries are submitted. You can do it by voice through a kind of a Google type of interface. Very popular, a lot of popular and interesting things that they've done that I see being replicated in the kind of the usual, the regular suspects of BI tools. The data lake, unstructured data. People are continuing to look for new solutions here. So a lot of it is in kind of maybe batch-oriented systems, and I see a lot of folks looking for new ways of doing that, and often just storing it in raw file systems, NoSQL databases to get that performance. Then on the far right, a host of tools out there, and one of the other sessions here today, converge.io. You can catch that sessions and hear on how they accelerate machine learning at an organization. Just to let folks know, it's a service that we provide at no charge, is the HPCEI Innovation Lab. And if you heard my talk before with the healthcare industry focus, is we have a facility south of the border, and it's a super cluster there built on Intel, one on AMD, and one on NVIDIA. And we use this to help our customers better understand the requirements of their AI algorithms. In one case with UBC, we helped accelerate their research, papers that they're writing as we speak. With other institutions, it's to better understand, should this go on, let's say, a GPU cluster versus a CPU cluster? And if so, how big should that cluster be? Being an optimist, the future does look promising. I mean, there are always new tools. That's one of the challenges of this industry, a never dull moment. And so sometimes it's a bit of the Wild West. No tool has really kind of stabilized or dominated so much that there's so few choices. There's always more and more choices out there. So popular use cases that we're seeing out here, machine learning to automate anomaly detection, data as a service, as I mentioned before, these data catalogs, and then this initiative, this drive to improve our data lakes, to house both structured, unstructured data, and giving them a way to access that data and manage that data. So, and to conclude on best practices, so the healthcare, I'm not going to change what I recommend as best practices, but number one is really to have a data-driven culture and to treat data as a shared asset. There are a lot of organizations, and including large ones, that really are totally fixated on just saving costs, where data is really not treated as an asset. So those organizations, while can continue to do somewhat well, where they're going to get left over are these organizations that can use and drive data for competitive advantage. And that's happening in every industry. To develop a strategy for AI, we recommend an architectural approach, as I mentioned before. And regardless of what use case that you drive, we find that every AI data analytics journey is unique. So with that, we'll end the presentation, and then we'll open it up for Q&A now.